Hello everyone, welcome back. In our previous video, we explored the methods of data collection, how we gather information through surveys, experimentation, and observation. But once data is collected, what is next? Raw data alone does not tell us much until it is organized and presented in a clear, meaningful way. That is exactly what we will focus on in today's lecture, method of data presentation. We will look at how to transform complex data sets into simple tables, clear diagrams, and effective graphs. By the end of this session, you will understand not only how to present data, but also why choosing the right presentation method is key to accurate interpretation and communication. Let's get started. Methods of data presentation. Data presentation is nothing but process of organizing, formatting, and visually displaying data. It transforms raw data set into meaningful formats such as tables, charts, graphs, infographics, or dashboard. While we present data, effective presentation of data helps us to simplify complex data and communicate effectively, facilitate comparison, and prepare for advanced analysis. Let us see some common terms on the course of data presentation. We will come across these three terms frequently. What the first is raw data. What is raw data? Data recorded in its original, unprocessed form is nothing but the raw data. Frequency, the number of observations or data points that fall within a specific class or category of a distribution is nothing but frequency. This term will also be frequent term in what follows. What the other thing is frequency distribution. This frequency distribution is nothing but a means of data presentation in a tabular form. So this frequency distribution is another name of tabular data presentation. This refers to a summary of raw data presented in tabular form, showing frequencies fall into each defined class or interval. So understanding these three terms is useful. In general, we do have three types of data presentation. One is textual presentation, second one tabular presentation, the third one is diagrammatic presentation. What the textual presentation refers for, this is nothing but narrative description of data using words. This description of data may be sufficient, while there is no need to present our data beyond that textual presentation. But the second one is tabular presentation, meaning that organizing data into rows and columns in the form of frequency distribution is nothing but the tabular presentation. What the third one is diagrammatic presentation, meaning displaying the data graphically, diagrammatically, right? Such as using bar chart, pie chart, histogram, line graph, frequency polygon, ogive, and much more. In this session, we will focus in the last two types of data presentation, on tabular presentation and diagrammatic presentation, as this textual presentation is a common one. In statistics, we have two methods of data presentation. One is the tabular presentation, the second one is graphical presentation. Under tabular presentation, we will have three types of tabular presentation. One is categorical frequency distribution, second one ungrouped frequency distribution, grouped frequency distribution. Categorical frequency distribution is useful to present qualitative data or categorical data, in particular for those nominal or ordinal scales of measurements, whereas ungrouped frequency distribution is useful to present for discrete data, such as family size of households, number of accidents, number of calls received by an operator, number of students, number of beds in a hospital, and much more. These all variables by their nature are discrete data, but they are quantitative. What the third tabular presentation is grouped frequency distribution, where this grouped frequency distribution is useful to present continuous data, height, weight, area, age, and much more. When we proceed to the graphical presentation, here we do have many graphical presentations. One is pie chart, bar chart, histogram, line graph, ogive, frequency polygon, stem and leaf, box plot, many other. What pie chart is presenting was the share of each category with respect to the whole. Pie chart presents in a sense that was the share of each category with respect to the whole. If you are interested, in this aspect of data presentation, we may use of this pie chart, whereas bar chart is useful for category comparison, right? This bar chart is nothing but a series of bars in a XY plane where the height of the bar is proportional to the frequency of the category, right? So through this data presentation, we can compare the category proportions or frequencies. So pie chart and bar chart are useful to present for those nominal and ordinal scale of measurement, in general for those qualitative variables or qualitative data. Whereas this histogram, line graph, ogive, these graphical presentation methods are useful to present continuous data. Histogram most of the time is useful to see distribution of the data. Line graph to train this over time. This is nothing but a time series plot. Ogive to indicate the cumulative frequencies. Cumulative frequency, it can be more than cumulative or less than cumulative frequency. So ogive is the extension of the frequency distribution, the group frequency distribution. Ogive data presentation is an extension of group frequency distribution. The same is true. Histogram is an extension of group frequency distribution. Before presenting our data graphic, what the first step to be performed is constructing the group frequency distribution, right? But it is not always to do so. But this histogram and ogive frequency polygon are nothing but the extension of group frequency, meaning that they need to be prior group frequency distribution before presenting the data using histogram and ogive. The general instruction of presenting data, how to present the data. The first step is choosing the right method based on data type. What we make as the first stage of presenting data is nothing but choosing the right method based on data type. The second one is organizing data clearly using tables, charts, or text. Then the third one, use visuals to highlight patterns and comparisons. At this stage, we add legends, colors, or extra visuals that strengthen the visuals for diverse audiences. While the first step is keep it simple and readable for your audience. While we present data, through this, we can present data effectively. These three types of frequency distributions are under the tabular data presentation. We will see this one by one in what follows. So let's begin with the categorical frequency distribution, CFD. How to construct categorical frequency distribution. Well, the first step is listing all distinct categories. If our data about colors may be red, black, white, yellow, blue. If we have raw data set consisting of these colors, well, the first step is identifying all distinct categories. If we have 4 colors, blue, red, white, black, so we identify 4 colors. Then, the second step is counting the frequency of each category. How many reds are there? How many blacks are there? How many whites are there? How many yellows are there? The tabular form, which is the rows and columns, which consists the possible distinct categories corresponding to their frequency of each category, is nothing but the frequency distribution now, right? The step 1 and the step 2 is the frequency distribution. But we can optionally compute relative frequency or percentage frequency. So let us see this example. This example talks about marital status data. A social worker collected the following data on the marital status of 25 persons. It was married, the second single, third divorced, widowed, divorced, single, right? In such a way that the social worker is collected this data. This from M to D is nothing but the raw data that we call raw data. The data in its original, right? Which is unorganized, not presented, right? This data is now raw data. What's the intention with this raw data is to make more organized, classified, and presented one. In doing so, as marital status is a variable which is qualitative variable or categorical variable, we make use of categorical frequency distribution to present such categorical variable. So what the first step is listing the distinct categories. What are the, in our example, what are those distinct categories? These are nothing but married, single, divorced, widowed. We do have 4 categories in our context, this example in particular. So we identify the classes or categories. Doing so, what the next step is counting the frequency of each category. Wow, let us count how many merit or M are in this raw data. We count how many M's. 1, 2, 3, 4, 5, 6 persons. 6 of them were merit. How many single persons are there? 1, 2, 3, 4, 5, 6, 7. 7, right? 7. Diversity, we have 7 also. Widowed, 5. So this is a simple frequency distribution that is easy to present the marital status of 25 persons collected by the social worker. So now it is simple and easy to talk with this frequency distribution meaningfully and in a clear way than talking with these individuals. This is more organized and clear and meaningful. Now from this table you can understand that which marital status, which class of marital status is dominant. Most of the persons were single and divorced, right? As relatively these are highest frequency. Single, divorced are 77, the list is widowed. So we can see something easily from this table than this raw data. Optionally, we can also compute from this table relative frequency or relative percentage, right? Rather than talking with this frequency, it would be better talking with percentages, right? The share of this category in percentage. Let us see. The relative frequency of each class or category is obtained by dividing the frequency of that class by the total number of observations. Here we do have 25 total observations in our raw data. Now we do have respective frequencies for each classes. For example, we do have 4 classes, 1, 2, 3, 4. The class of the first class is 6. 6 divided by 25 is nothing but the relative frequency, 0.4. 7 divided by 25 is 0.8. This is the relative frequency. 7 divided the same. 5 divided by 25 is 0.20. When we multiply this relative frequency by 100, we come up with the percentages, relative percentages, right? This is nothing but percentage frequencies, the relative frequency multiplied by 100. Then we come up with the last element, this one. This percentage element sums to 100, whereas the relative frequency sums to 1. So relative frequency is all about probability. This is nothing but the categorical frequency distribution with the example of marital status. Thank you.